Hello everyone, in this video we will review AP, Calculus AB and BC topic analyzing a function based on its derivatives. Alright, first we're going to talk about the increasing and decreasing of the function. Alright, so in order to determine if the function is increasing, we need the first derivative f prime of s greater than 0. The function f of s decreasing. Now if f prime of s less than 0, then the function f is decreasing, right? Now in order to determine the relative or local extrema of the function, we have two different ways to do it. The first way, we can use the first derivative test. We need to find the critical numbers. Critical numbers are s value that makes f prime equals 0 or undefined. Then you're gonna set up the side charts. Suppose you have the critical number c right here, right? On the left of c is gonna be negative. On the right of c is gonna be positive, right? Then the function is decreasing, then increasing. This one is relative minimums, right? Similarly, if you have the critical number c, on the left of c is going to be positive, on the right of c is going to be negative. Then the function is increasing, then decreasing. This one is relative maximum, right? Now, the second way to do this one is to use the second derivative test. We still use the critical numbers right here, right? So if f double prime of c greater than 0, the function has the relative minimum, right? If f double prime of c less than 0, the function has the relative maximum, right? Now, if f double prime of c equals 0, the test fails, right? Move on to the next one. In order to determine the absolute or global extrema, we're going to use the candidate test. Normally, you will see the closed interval, a and b. Alright, so suppose you have the critical number c. Now, what you need to do is to find f of c, f of d, f of a. Don't forget to include the endpoints right here. And f of b. Alright, so suppose f of c equals 10, f of b equals 2, f of a equals 4, f of b equals 11. Alright, so you can conclude that this one is the global maximum. The smallest one is the global minimum, right? So the global minimum right here. Now, in order to determine the concavity of the function, we're going to use the second derivative, right? So if f double prime of s greater than 0, right? Or f prime of s is increasing, right? Then the function f of s is concave up, right? It's going to be like this. Or sometimes we're going to cut this one in half, so it can be something like this guy. Or like this, right? Now similarly, if f double prime of s less than 0, or f prime of s is decreasing, right? Then f of s is concave down. It's going to be like this. Or if you cut this one in half, it's going to be something like this. Right? It's still concave down. Right? Now, next one, in order to determine the point of inflection, it means the point where the concave changes, right? We're going to use the first derivative. The graph of the function f has a point of inflection where f prime changes from increasing to decreasing or decreasing to increasing. Now, another way to find the points of inflection is to use the second derivative. Alright, so the first thing you need to do is to solve the function f the program of s equals 0. Alright, so suppose I have s equals c. And you need to find the value of s where f the program of s is undefined. Right? And then you're going to draw the side charge or the number line, right? So suppose I have C right here, right? And on the left of this one is going to be negative infinity, this one is positive infinity, right? And suppose this interval has the negative side, this interval has the positive side, right? Now, within this interval, the function f the program of s is negative, right? Which means the function is concave down, right? And this one is going to be concave up, right? So this point is the point of inflection, right? So if you graph it, it could be something like this. Alright, so the point of inflection is right here. Now similarly, suppose you have the side charge as follows. C right here. This is negative infinity, positive infinity, right? And this interval is positive, this interval is negative, right? So, if the program is positive within this interval, the function concave up, right? If the program is negative within this interval, the function is concave down, right? So, if you graph it, it's going to be something like this. Alright, so the point of inflection is right here. Now, one thing you need to remember is that the side charge does not give you credit on the AP exam. The side charge only helps you make determination if the function is increasing or decreasing. The function has a maximum or minimum. The function is concave up or concave down. That's it. Alright, so in order to earn full credit on the AP exam, you must justify your answer using the following. For example, the question wants you to determine if the function is increasing or decreasing on the interval a and b. You need to say the function f of s is increasing on the interval a and b because f prime of s greater than 0. The function f of s is decreasing on the interval a and b because f prime of s less than 0. Similarly, in order to determine the relative minimum, maximum, or point of inflection, you need to say that the function f of s has a relative minimum at a point s equals a. Because f prime of s changes signs from negative to positive when s equals a. The function f of s has a relative maximum at a point s equals a. Because the function f prime of s changes sign from positive to negative when s equals a. The function f of s has a point of inflection at a point s equals a. Because f the program of s changes sign when s equals a. Alright, so the best way for you to memorize this one is to use the side charts. For example, you have the number line right here, and you have the critical number right here, right? So the left side right here has the positive sign. The right side is negative, right? So the function is increasing and decreasing, right? So this one is relative mass, right? Similarly, this one is relative minimum, right? For the inflection points, you have the side chart for the second derivative, right? Suppose this one is a, right? So it's going to be negative and positive right here. So f double prime is negative and f double prime is positive right here, the function is concave down and then concave up like this, right? So the point of inflection is right here. Or if you see something like this, the function is concave up, then concave down like this, alright? Then the point of inflection is right here. Now let's move on to question 1. The graph of y equals fs is shown in the figure above. On which of the following intervals are dy over ds greater than 0? This one is the same thing as f prime of s greater than 0, right? And d squared y over ds squared less than 0. This guy is the same thing as f double prime of s less than 0, right? So this one greater than 0 tells us that the function f of s is increasing, right? And this guy tells us that the function f of s is concave down. So it could be something like this or like that, right? Now we explore the graph right here. The function is increasing, right? So it's gonna be this interval only, right? Because this interval is decreasing, right? So you need to eliminate C and D right here, right? Now, f double prime of s is less than 0, which means the function is concave down, right? So concave down is right here, right? This guy is concave up, right? So the answer must be B to C. So it could be right here. So the answer must be B. Now let's move on to question 2. The graph of a choice differentiable function f is shown in the figure above. Which of the following is true? Alright, f1 less than f prime of 1 less than f double prime of 1, or B, C, D, and E, right? So in order to do this one, we need to use the Christmas tree trick, right? If the graph's going up like this, the slope is positive, the function is increasing, right? If the graph is going down like this, the slope is negative, the function is decreasing, right? If the graph is horizontal, the slope is 0, right? If the graph is vertical, the slope is undefined, right? Now, we look at this one right here, we see that this is the function f of s, right? So f of 1 equals 0, we write over here f of 1 equals 0, right? Now, f prime of 1, we're going to draw the tangent line at 1, right? So it could be something like this, right? So the slope is positive, right? Right here. So we have f double prime of 1 right here, positive, right? Now next one, right at 1, the function is concave down, look, right? So f double prime of 1 right here must be less than 0, right? Now we're going to compare this one, of course, f double prime of 1 less than f of 1 less than f prime of 1, right? Based on this guy right here, right? So the answer must be D, right? Now let's move on to question 3. The function f is given by fs equals s to the 4 plus s squared minus 2. On which of the following intervals is f increasing, right? So f increasing, which means f prime of s greater than 0, right? So we need to take the derivative of the function fs is to be 4s cubed plus 2s, right? We need to find the critical number, right? So we're gonna let f prime of s equal to 0. This guy is the same thing as 4s cubed plus 2s equals 0. Factor 2s out. So we have s squared plus 1 equal to 0. Now this one is the 0 product, right? So we have either 2s equals 0 and s squared plus 1 equals 0, right? So we solve for s, we only need s equal to 0, right? This one is undefined because this guy always greater than equal to 1, which is greater than 0, right? So we only have one Greco number, right? We're going to use the side charge right here, right? So we put 0 right here. The left side is negative infinity. The right side is positive infinity because the domain of the polynomial function is real numbers, right? Now we're going to test value, right? So I'm going to pick 1 in this interval, right? I substitute 1 for s back to the function f prime of s right here, right? So I have 4 times 1 cubed plus 2 times 1, which is positive, right? So this interval positive, this guy automatically negative, right? So the function is decreasing and increasing right here, right? So we look at this one, we see that the function f is increasing on the interval 0 to infinity. The answer must be C. Now question 4. Given the function defined by ls equals 3s to the 5th minus 20s cubed, find all values of s for which the graph is concave up, right? So the function is concave up if f the program of s greater than 0, right? Now we're going to take the derivative of this one, so f prime of s equals 15 s to the 4 minus 60 s squared, right? And f the program of s equals 60 s cubed minus 120 s, right? We need to let f the program of s equals 0 to solve for s, right? So we have 60 s cubed minus 120 s equals 0. Factor 60 s out. So we have s squared minus 2 equals 0. And then we're going to use the 0 product, right? So 60s equals 0 and s squared equals 2, right? And then this guy becomes s equals 0 and s equals plus and minus root 2, right? So we're going to use the number line, right? So put these critical values on the number line. The first one is negative root 2. The second one is 0. The third one is root 2, right? The right side is positive infinity. The left side is negative infinity, right? Now we're going to test the number. So I'm going to pick the number 1 right here, right? Substitute 1 for s into the second derivative right here, right? So we have 60 times 1 cubed minus 120 times 1, which is negative, right? So this interval is negative. This guy must be positive. This guy is positive and this guy is negative. You just keep changing sign, right? If you don't have the even multiplicity. But if you have even multiplicity, you need to be careful. The function passing the root that has even multiplicity, the sign does not change. So keep that in mind. Now, we need the function to be concave up, which is f the prime of s greater than 0, right? So the interval should be this guy right here. This guy right here, right? So we look at the answer choice. It's going to be negative root 2 to 0 and root 2 to infinity, right? It's going to be B right here. Now let's move on to question 5. What are all values of s for which the function f is divided by ls equals s squared minus 3 times e to the negative s is increasing, right? So we need f prime of s greater than 0, right? So we take the derivative of this one. We're going to use the product rule, right? So it's going to be 2s times e to the negative s, right? Minus e to the negative s times s squared minus 3, right? Now I want to factor e to the negative s out, right? So I have 2s, negative 1 times s squared could be negative s squared. Negative 1 times negative 3 could be positive 3, right? So I need to let f prime of s equals 0 is the same thing as this guy right here always positive, right? So I don't need to worry about this one, right? So it could be negative s squared plus 2s plus 3 equals 0, right? So I multiply both sides by negative 1, so it could be s squared minus 2s minus 3 equals 0, right? Factor this one, it could be s minus 3 times s plus 1 equals 0, right? So s equals 3 and s equals -1, right? So I'm going to use the number line, right? So I put -1 right here and 3 right here. The right hand side is positive, the left hand side is negative, right? Now I'm going to test one interval, right? So I'm going to put 0 right here, right? So I substitute 0 for s back to the f prime of s right here, right? So I have this one 0, right? This one becomes negative e to the 0 is to be 1 times 0 minus 3, right? So it's to be 3, which is positive, right? This one positive, this one negative, and this one is negative, right? Now we need the function to be increasing, which is f prime of s greater than 0, right? So only this interval works, right? So the answer must be -1, 2, 3, right? So it will be D. Now let's move on to question 6. If f the program of s equals s times s plus 1 times s minus 2 squared, then the graph of f has inflection points when s equals how much, right? So we need to find the critical numbers right here, right? So we have f the program of s equals 0, right? So it could be s equals 0, right? And s plus 1 equals 0, s equals -1, right? S minus 2 equals 0, s equals 2. But this one is even multiplicity. Alright, so you need to be careful with this guy. Alright, so we're gonna draw the number line right here. We're gonna place -1, 0, and 2 on the number line, right? Now we're gonna test the interval, right? So I'm gonna pick 3 right here. So I substitute 3 for s back to the function right here, right? So I have 3 times 3 plus 1 times 3 minus 2 squared, always positive, right? So this interval is positive. Now write s equal 2. We have even multiplicity, which means the function bounces back. The sign does not change, right? So this guy positive, this guy must be positive. Keep that in mind. Now write x 0 and -1. We don't have even multiplicity, so the size keeps changing, right? So this is positive, this guy must be negative, and this guy is positive, right? We need to find the inflection points, which means the sign of the second derivative changing, right? So the sign changes at this point and at this point. Look, positive to negative and negative to positive. At this point, the sign doesn't change, right? So the answer must be s equal -1 and 0 only, right? The answer must be C. Now let's move on to question 7. The derivative g prime of a function g is continuous and has exactly 2 zeros. Select the values of g prime are given in the table above. If the domain of g is a set of all real numbers, then the function g is decreasing on which of the following intervals? The function g is decreasing. It tells us that g prime of s must be less than or equal to 0, right? So we look at the table right here, g prime of s right here, right? So the values that less than or equal to 0 are -3, -2, -1, and 0, 0 right here. So the interval must be from here to here, right? -2 to 2, the answer must be A. Now, question 8. The function y equals fs is differentiable and decreasing for all real numbers. On what interval is y equals f of s squared minus 4s decreasing? This one is the composite function, right? We need to take the derivative of y. It's going to be s squared minus 4s prime times f prime of s squared minus 4s, right? So it's going to be 2s minus 4 times f prime of s squared minus 4s, right? Now we need to find the critical numbers for this one, right? So we left y prime equals 0 is the same thing as 2s minus 4 times f prime of s squared minus 4s equals 0, right? Now this guy is the same thing as 2s minus 4 equals 0 and f prime of s squared minus 4s equals 0, right? But this one cannot be equal 0, right? Look at this one right here. The function y equal fs is decreasing for all real numbers, right? So which means this one right here always less than 0, right? So we only need this one right here equal 0. We solve for s, so s equals 2, right? So we set up the side jobs, right? So we put 2 on the number line and then go from negative infinity to positive infinity, right? Now we need to test the interval, right? So suppose I'm going to pick 0 right here, right? So substitute 0 back over here, y prime right here, right? So I have negative 4 times a number right here less than 0, right? So it's going to be positive, right? So this interval has the positive side and then this interval has the negative side, right? So the function is increasing on this interval and decreasing on this interval, right? Now we need to find the interval where the function is decreasing, right? So the function is decreasing on the interval 2 to infinity, right? The answer must be C. Now let's move on to question 9. For all s in the closed interval 2 to 5, the function f has a positive first derivative. It tells us that f prime of s greater than 0, right? The function f of s is increasing, right? And a negative second derivative. It tells us that the function of the first derivative of s is decreasing, right? Now we're going to combine this guy and this guy. It tells us that the function is increasing at a decreasing rate. Alright, now we need to eliminate the answer choice C, D, and E because the function is decreasing. Look at the y value right here. It keeps decreasing, right? 16, 14, 11, 7, and 16, 13, 10, 7, right? Now, only the y values right here increasing, right? So it's match the first one right here. Now we need to find the rate of change and make sure the rate of change is decreasing, right? So now we need to find the change from 9 to 7 plus 2 plus 3, right? And this is plus 4. This one plus 4 plus 3 and plus 2, right? So the rate of change for the first table right here is going to be 2 divided by 1 and 3 divided by 1, right? Right here, 1. And 4 divided by 1. And you see that the rate of change is increasing, right? For this one right here, you have 4 divided by 1, right? 3 divided by 1 and 2 divided by 1, right? The rate of change is decreasing, right? So it matches this guy right here, decreasing, right? So the answer must be B. Now let's move on to question 10. Let f be the function defined by Ls equals s cubed minus 3s squared, on which of the following intervals is f prime both positive and decreasing, right? So we need to find f prime of s equals 3s squared minus 6s, right? So we need to let f prime of s equals 0, right? So it could be 3s squared minus 6s equals 0, right? Factor 3s out, so it could be s minus 2 equals 0, right? So you have 3s equals 0 and s minus 2 equals 0. This guy is the same thing as s equals 0 and s equals 2, right? So we're going to draw the number line, place 0 and 2 here. The left side negative infinity, the right side is positive infinity, right? Now, I need to test an interval, right? So I pick 1 right here. Substitute 1 for s back to the f prime of s right here, right? So we have 3 times 1 minus 6 times 1, right? and it's going to be negative 3, which is less than 0, right? So this guy has a negative sign, right? We don't have even multiplicity, so the sign keeps changing, right? This one positive and this one's positive, right? Now, the function f prime is positive within this interval, right? Now, we need to find the interval where f prime is decreasing. F prime is decreasing. It tells us that f double prime of s must be less than 0, right? We need to find the second derivative of s, right? We're going to take the derivative of this one, right? So it can be sit s minus sit. We're going to let this one equal 0, right? So s equals 1, right? So we're going to draw the number line right here. Negative infinitive, positive infinitive, and 1 right here, right? This one is the critical number, right? So we're going to test the value. I'm going to pick 0 right here. I substitute 0 for s into the second derivative function right here, right? So I have sit times 0 minus sit is going to be negative sit less than 0, right? So this interval has the negative sign. This interval has the positive sign, right? So we need to find the interval where double prime of s less than 0, right? Which is this guy right here. Finally, we need to find the intersection between this interval, and this interval, right? So the only intersection that satisfies this condition is negative infinitive to 0, right? So the answer must be A. Now let's move on to question 11. If f of s equals s squared times e to the s, then the graph of f is decreasing for all s such that, right? So we need to find the first derivative, right? So f prime of s equals, use the product rule, right? So it will be 2s e to the s plus s squared e to the s, right? So we're going to factor e to the s out. So it will be 2s plus s squared, right? We're going to let the first derivative equals 0. So it's going to be 2s plus s squared equals 0, right? We don't need this one because it's always positive, right? So we're going to factor s out. So it will be 2 plus s equals 0. And then s equals 0 and s equals negative 2, right? Now we're going to draw the number line. Negative 2, 0, negative infinity, positive infinity, right? Now we're going to test the interval. So I'm going to pick one right here. So I substitute back to this one, right? So it's always positive, right? So this one positive, negative, and positive, right? Now we need to find the interval where the function f is decreasing, right? Which is f prime of s less than 0, right? So only interval that satisfies this condition is negative 2 to 0, right? So the answer must be B. Now let's move on to question 12. Three graphs labeled 1, 2, 3 shown above. One is the graph of f, one is the graph of f prime, and one is the graph of f double prime. Which of the following correctly identifies each of the three graphs, right? So we have f prime, f double prime, and the order right here, right? So let's review a little bit about the relationship between f prime, and f double prime, right? So we'll look at this one right here. Now remember, the relative minimum or maximum of the function f of s will be the 0 of the function f prime of s. So we'll look at this one right here. Similarly, the relative extrema of the function f prime of s will be the zeros of the function f double prime of s. So keep that in mind, alright? One more thing you need to consider is the inflection point of the function f of s will be the relative minimum or relative maximum of the function f prime of s. So it can be like this, right? Alright, so keep that in mind. Now we're going to go back over here. Observe that this guy has the relative mass, right? When S equals 1 point something, suppose it was 1.3, right? And this one relative minimum, right? It's gonna be 1, 2, 3, 4, 4.6 something, right? This guy right here must be the zero of the function f prime of s, right? So suppose this one is the function f of s. Now we look at f prime. So we look at this one right here, the zero right here. 1.3 something, right? This one right here, 1, 2, 3, 4, 4.6 something, right? So this one must f of s. This one f prime of s, right? Now we look at the maximum right here and minimum right here. So maximum is at s equals 0.5 and minimum is at s equals 1, 2, 3, right? These two values right here becomes the zero of the function f double prime, right? So 0 right here, right? 0.5 and this one 1, 2, 3, right? So this one is f double prime of s, right? So the answer must be 2, 3, and 1, right? 2, 3, 1, the answer must be C. Now let's move on to question 13. Let f be the function given by Ls equals cosine 2s plus ln 3s. What is the least value of s at which the graph of f changes concavity? Now, since this one is the calculator active problem, right? So we need to find the least value of s at which the graph of f changes concavity, right? So we need to find the first derivative of s. Right? It's gonna be negative 2 sine 2s plus 3 over 3s, right? So we're gonna simplify. It's gonna be negative 2 sine 2s plus 1 over s, right? So we're gonna print out the calculator. Now you either calculate the derivative by hand or you can use the calculator. Since the question allows you to use calculator, right? So I'm gonna add calculator, right? So I'm gonna hit f of s. Now I need to store the function. So I need to hit control and the button right here. And I just input the function. It could be cosine 2s plus ln 3s. So I'm gonna hit trick right here, cosine 2s plus ln control ln 3s and then press enter. Done, right? Now you need to find the first derivative, right? So you're gonna hit the button right here and find the first derivative. It's gonna be right here. Derivative of this function with respect to s, right? And then press enter. It's gonna be right here. Now you need to grab this one, right? So you're gonna go to home screen, hit graph right here, alright? F1 of s, which is hit graph. Now the question wants you to find the least value of s at which the graph of f changes concavity. It's the same thing as finding the least value of s where f prime of s changes from increasing to decreasing or decreasing to increasing, which is we need to find the smallest value right here, right? So we need to hit menu, go to number set and find the minimum of this one, right? It's gonna be this guy right here. The answer is 0.93, right? So the answer must be B. Now let's move on to question 14. Let f be a function that is continuous on the closed interval negative 2 to 3, such that f prime of 0 does not exist. F prime of 2 equals 0 and f double prime of s less than 0 for all s except s equals 0. which of the following could be the graph of the function f, right? So we're going to look at this one right here. The function must be continuous, right? So we're going to eliminate answer choice D, right? Because the function is discontinuous at s equals 0, right? Next one, f prime of 0 does not exist. It tells us that the function f is not differentiable at s equals 0, right? So normally you're going to see the sharp turn like this. Oh, the function is discontinuous, right? So you're going to eliminate answer choice C, right? Because the function is differentiable right here, right? Now, f prime of 2 equals 0, s equals 2 is a critical number, right? So it's normally is where the function has the maximum or minimum. So we look at s equals 2, we have the minimum right here, maximum right here, maximum. Now, lastly, add the program of s less than 0 for all s except s equals 0, right? It tells us that the function fs is concave down, right? It's either this one or this one or this one like this, right? So we look at the answer choice right here. This one concave down, right? So the answer must be E, right? This one is concave up. This one is concave up, right? Now, question 15. Let f be the function with derivative defined by f prime of s equals psi s cubed on the interval -1.8 to 1.8. How many points of inflection does the graph of f have on this interval? Now, you have two different ways to do this problem. If you use the function f prime of s, and then you need to count to see how many times f prime of s changes from increasing to decreasing, or decreasing to increasing, right? Or you can use the second derivative of s, and you need to count how many times the function f, the program of s, changes sign on the interval -1.8 to 1.8, right? So I'm going to use the second derivative of s to do this one, right? So I'm going to print up the calculator. Now I need to take derivative of this one, right? So I'm going to hit the button right here and derivative right here with respect to s, and then I'm going to input sine of s cubed, right? And then press enter. It could be 3s squared times cosine of s cubed, right? So I'm going to go to the graph. I'm going to input and then press enter. Now I need to restrict the domain from -1.8 to 1.8, right? So I'm going to hit menu number 4 right here, Windows series right here, -1.8 to 1.8. Okay, it's going to be right here. Now observe that the function at the program of s changes sign from positive to negative right here, right? And negative to positive, right? And positive to negative right here, and negative to positive right here. Totally, you have 4 times at the program of s changes signs on this interval, right? So we're going to go back over here. The answer must be C. Now let's move on to question 16. If the derivative of f is given by f prime of s equals e to the s minus 3s squared, ask which of the following values of s does the function f has a relative maximum value, right? So we're going to use the calculator, right? So in order for the function f to have a relative maximum, the function f prime of s must change sign from positive to negative, right? This one is mass. Now, if negative to positive, this one is minimum, right? So we don't need this one, right? We need this one right here. So we're gonna print up the calculator. Alright, so it's gonna be right here. The part of the function above the axis is positive, and the other part of the function below the axis is negative, right? So positive to negative. This one is the relative maximum. This one right here is the relative minimum. So keep that in mind, right? So we need to find the intersection right here, right? So we need to hit menu, number, set, and hit zeros right here. Go to the left. Go to the right, the answer is 0.91, right? So the answer must be C. Now let's move on to question 17. If g is a differentiable function such that g of s less than 0 for all real numbers s, and if f prime of s equals s squared minus 4 times g of s, which of the following is true? Alright, so the question wants you to determine the relative minimum or relative maximum, right? So think about the first derivative, right? So we need to find the critical number, right? So we're gonna let f prime of s equals 0 is the same thing as s squared minus 4 equals 0, and g of s equals 0, right? But g of s always less than 0, right? So we don't need to worry about this one, right? So we have s equals plus and minus 2, right? We're going to draw the number line. Put negative 2 here, positive 2 here, right? Negative infinity, positive infinity, right? Now we're going to test the number, right? We're going to pick 0. Substitute here. It's going to be 0 minus 4. It's going to be negative 4 less than 0, right? So within this interval, the function f prime of s has the negative number, right? This one is positive, this one is positive, right? So this one is the side charge for s squared minus 4, right? Now we need to create a side charge for g of s, right? Now the function g of s is always less than 0 for all real numbers, right? So this one negative, 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 right? Now we need to find the side charge for f prime of s, right? So f prime of s, we need to multiply g of s and this guy, right? So positive times negative is going to be negative. Negative times negative is going to be positive. Positive times negative is going to be negative, right? And we have negative 2 right here and 2 right here. F prime of s is less than 0, the function is decreasing, right? This one increasing, this one decreasing, right? So this is relative minimum, and this one relative maximum. So the answer must be B. Now let's move on to question 18. The graph of the function h of s is shown above. Which of the following could be the graph of the function h prime of s, right? So we're gonna review this one right here. Remember, the relative minimum or relative maximum of the function f of s becomes the 0 of the function f prime of s, right? So we're gonna go back over here. We need to eliminate the wrong answer, right? So we see the relative maximum right here and relative minimum right here, right? We need to eliminate A and B, right? Because there is no 0 right here, right? And this guy, there's no 0 right here, right? Within this interval, the function is increasing, right? So you just draw the tangent line. The slope of the tangent line is positive, right? Which means the function h prime of s is above the axis, right? Because the slope is positive, right? So you see that this one above the axis, right? Similarly, for this one right here, the function is increasing, right? The function f prime of s must be positive, right? And it's going to be above the axis right here, right? Now look at this one right here, this guy below the axis, so the answer C is wrong, right? Now only D and E could be the answer, right? Now we look at the interval right here. You see that the function is concave down within this interval, right? It tells us that f, the program of s, must be less than 0 on this interval, right? If f the prime of s less than 0, the function f prime of s is decreasing on that interval, right? And when f prime of s decreasing on that interval, the slope of the tangent line must be negative, right? Remember the Christmas tree trick. This one positive, negative, 0, and undefined, right? So we draw the tangent line of the function f prime of s right here. We see that the slope is negative, right? Now we look at this one, we draw the tangent line right here, is slope negative, right? But this interval right here, the slope is positive, right? So we're gonna rule out the answer choice, the only E correct, right? Now let's move on to question 19. The graph of the derivative of the function f is shown in the figure above. Which of the following could be the graph of the function f, right? So we look at this one, the shape of the function f prime of s is quadratic, right? So the original function must be cubic, right? So we need to eliminate the answer A and B, right? Because they are linear, right? Now only C, D, E could be correct, right? We look at this guy right here. The zero of the function f prime of s will be the relative extrema of the function f of s, right? So f were negative 2 and 2. We need to look for the relative extrema, right? So it could be right here and right here. This one is wrong, right? Because it's not negative 2 and 2, right? This one could be right? Negative 2 and 2 right here, right? Now, the last one, from negative infinity to negative 2, the function f prime of s is below the axis, right? So within this interval, f prime of s less than 0, right? It tells us that the function f of s is decreasing on this interval, which is negative infinity to negative 2, right? So the function is decreasing, which means the slope of the tangent line is negative, right? So we draw the tangent line right here. We see that the slope is negative within this interval, right? Remember the Christmas tree trick, positive, negative, 0, undefined, right? So the answer must be E. Now let's move on to question 20. The function f is given by f of s equals s cubed plus 3s squared minus 9s minus 4. What is the absolute maximum value of the function f on the closed interval negative 4 to 2? Alright, so we need to use the candidate test, right? Check the first derivative of this one. So we have f prime of s equals 3s squared plus 6s minus 9. Let f prime of s equals 0, right? So we have 3s squared plus 6s minus 9 equals 0. Divide both sides by 3. So we have s squared plus 2s minus 3 equals 0. Factor this one out. It's going to be s plus 3 times s minus 1 equals 0. S equals negative 3 and s equals 1, right? Now I'm going to show you the shortcut to solve this one without factoring, right? So if you have as squared plus bs plus c equals 0. Now if a plus b plus c equals 0 and you have two solutions, s equals 1, s equals c over a. Now, if you have a minus b plus c equals 0, you have two solutions, s equals negative 1 and s equals negative c over a, right? So I'm going to apply this shortcut, right? So I have a plus b plus c equals 1 plus 2 minus 3 equals 0, right? So I'm going to apply the first one right here. S equals 1. S equals c over a, which is negative 3 over 1. This could be negative 3. So this could be right here, right? Now we're going to use the candidate test, right? So we need to calculate f of negative 3, f of 1. Now don't forget the endpoints right here. So f of negative 4 and f of 2. F of negative 3, substitute negative 3 for s back to the original function right here. So we have negative 3 cubed plus 3 times negative 3 squared minus 9 times negative 3 minus 4. It's going to be 23. Now f of 1, substitute 1 for s over here, negative 9, right? Now f of negative 4 is going to be 16, right? And the last one, f of 2 is going to be negative 2, right? Now the absolute maximum values of the function f on the closed interval is 23, right? So the answer must be D. Now let's move on to question 21. The figure above shows the graph of f prime, the derivative of a choice differential function f on the interval negative 3 to 4. The graph of f prime has a horizontal tangent line x equal negative 1, 1, and 3. So it could be right here. The areas of the region bounded by the x-axis, the graph of f prime on the interval negative 2 to 1 and 1, 4, and 9 and 12 respectively. So the area of these regions right here and the regions right here are 9 and 12, right? Question 8. Find all x coordinates at which the function f has a relative maximum. Alright, so when it comes to relative extrema increasing, decreasing, think about the first derivative, right? So we need to find the critical numbers first, right? Critical numbers is where f prime of s equals 0, right? So you have critical numbers right here, negative 2, 1, and 4, right? So we have f prime of s equals 0. Then we have s equals negative 2, s equals 1, and s equals 4, right? Now, in order to find the relative maximum, we need to create the side charts, right? So remember, if f prime of s changes sign from positive to negative, the function has the relative maximum, right? Or the function f prime of s changes sign from negative to positive, the function fs has the relative minimum, right? The function f prime of s is positive when it's above the axis, right? So we look at this one, this guy above the axis, so it could be positive here, right? This guy is negative, this guy is negative, this guy is negative, and this guy is still negative, right? So only this interval is positive and this interval negative, right? So the function f prime of s changes sign at this point, right? And only this point has the relative maximum, right? So you need to say f of s has a relative maximum at s equal negative 2 because f prime of s changes sign from positive to negative at s equal negative 2, right? Now question B. On what open intervals contained in negative 3 to 4 is the graph of the function f both concave down and decreasing, right? So if the function f is concave down, you have f the prime of s must be less than 0, right? And the function f is decreasing, you have f prime of s must be less than 0, right? So it tells us that the function f prime of s must be below the x-axis, right? And at the prime of s less than 0, it tells us that the function f prime of s is decreasing, right? Now we need to look for the interval that below the axis, right? So it could be this guy right here, right? And f prime of s is decreasing, which means the slope of the tangent line is less than 0, right? So it could be this guy right here and this guy right here, right? So the answer must be negative 2 to negative 1 union 1, 2, 3, right? Question C. Find the x-coordinates of all points of inflection for the graph of f. Alright, now the function f has point of inflection if f prime of s changes from increasing to decreasing or decreasing to increasing. Another way to do this one is we're going to use the second derivative. right? So the function f has points of inflection if the program of s changes sign from positive to negative or negative to positive, right? So we look at this one right here. This one is the function f prime of s, right? We just draw the tangent line, right? We draw this one right here and this guy right here. And we see that the tangent line is going down, the slope is negative. Tangent line is going up, the slope is positive. Similarly, we draw the tangent lines right here, right? It's going to be negative. Tangent lines right here, it's going to be positive, right? So we see that as the program of s changes sign from negative to positive, s equals negative 1, right? From positive to negative, s equals 1, right? And from negative to positive, s equals 3, right? So we can say that the s-coordinate of all points of inflection for the graph of f are s equals negative 1, s equals 3, because at the program of s changes sign from negative to positive, right? And s equals 1 because at the program of s changes sign from positive to negative, right? Now let's move on to question 22. Consider a differentiable function f having domain of all positive real numbers, and for which it's known that f prime of s equals 4 times s to the negative 3 for s greater than 0. Question A. Find the s-coordinate of the critical point of f, right? So we need to let f prime of s equals 0, right? So it could be 4 minus s times s to the negative 3 equals 0, right? So it's going to be 4 minus s over s cubed equals 0, right? So in order to find the critical number, we need to let the numerator equal 0, right? So I have 4 minus s equals 0. And where the function f prime of s is undefined, right? So which means the denominator must be equal 0. So s cubed equals 0, right? So it's going to be s equals 4 and s equals 0, right? But we look at this one right here, the domain s greater than 0, right? So we don't need this one, right? Now determine whether the point is a relative maximum, minimum, or neither for the function f, right? So we're gonna use the side charts, right? So we put 4 right here, right? So it could be 0 right here and infinity right here. Now we're gonna test the interval, right? So I'm gonna pick 1. Substitute 1 for s into the function f prime of s right here. Right? So it's gonna be positive, right? This guy positive, this guy must be negative, right? So the function is increasing and decreasing. This one is relative maximum, right? So we need to conclude that the function f has a relative maximum at s equals 4 because f prime of s changes sign from positive to negative at s equals 4, right? Now question B. Find all intervals on which the graph of f is concave down, right? It tells us that you need to use the second derivative, right? So we take the second derivative of this one, right? We're going to use the product rule, right? So it will be negative 1 times s to the negative 3, right? Minus 3 times 4 minus s times s power of negative 4, right? So it's going to be negative 1 over s cubed minus 3 times 4 minus s over s to the 4, right? Now we need to rewrite this one in the same denominator, right? So I'm going to multiply the top bottom of this one by s, right? So I have negative s minus, distribute this one, it could be 12. And it's going to be plus 3s over s power 4, right? Now I'm going to simplify this one, so it could be 2s minus 12 over s power 4, right? We need to find the critical number for this one, right? So f the program of s equals 0 when 2s minus 12 equals 0 and where the function is undefined, right? Which means s equals 0, right? So we solve this one, it's going to be s equals 6 and s equals 0. But the domain is s greater than 0, right? So we just ignore this guy, right? So only have 6, right? So we need to use the side jobs, right? So we put 6 over here, and it's going to be 0 and positive infinity right here, right? And now I'm going to test the interval, right? So I pick 1. Now I substitute 1 back to this one right here, right? So I get negative number, right? So it should be negative, this one should be positive, right? The function f is concave that it tells us that f the program must be less than 0, right? So this interval right here has f the program less than 0, right? So we need to conclude that the function f is concave down on the interval 0 to 6 because f the program of s less than 0, right? Now let's move on to question 23. The figure above shows the graph of f prime, the derivative of f, for s between negative 7 to 7. The graph of the function f prime has a horizontal tangent line s equals negative 3, 2, and 5, right? So it could be right here, and right here. And a vertical tangent line s equals 3. So s equals 3, we have the vertical tangent line. Now question A. Find all values of s for s between negative 7 and 7 at which the function f attains a relative minimum, right? The function f attains a relative minimum when the function f changes from decreasing to increasing, right? Or f prime of s changes sign from negative to positive, right? So we look for the graph right here. This one is f prime of s, right? So anything above the axis should be positive, below the axis should be negative, right? So the interval changes from negative to positive is to be right here, right? So the relative minimum at s equals negative 1, right? Question B. Find all values of s for s between negative 7 to 7 at which the function f attains the relative maximum. Alright, we do exactly the same thing, right? So it should be f prime changes sign from positive to negative. Or the function f is increasing and then decreasing, right? So we look at this one from positive to negative. It's going to be right here, right? Positive to negative. So s equals negative 5, right? So we need to say that the function f attains a relative maximum at s equals negative 5. Since the function f prime of s changes sign from positive to negative, s equals negative 5. The last question, find all values of s for s between negative 7 to 7 at which f the program of s less than 0, right? It tells us that the function f of s is concave down, right? Either this one or it could be something like this, right? So it means the function f prime of s is decreasing, right? And f the program of s exists. Now we need to find the interval where the function f prime of s is decreasing and f the program of s exists, right? So it's going to be this interval right here, right? And this interval right here, right? Now we need to exclude s equals 3. Why? Because at this point you have the vertical tangent line of the function f prime of s. It tells us that the function f prime of s is not differentiable at s equals 3. In other words, and the program of 3 is undefined, right? So the answer must be the number negative 7 to negative 3 union 2 to 3 union 3 to 5, right? Because f the program of s exists and f prime of s is decreasing on these intervals. It's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.